the rear, the car in front. This is the control panel that controls the rear bumper. So we are actually showing up the speed. So right now we're showing the speed according to our communication protocol, and that's the car in front. So let's have you turn on your headlights to normal beam, low beam. Okay, so this is headlights at low beam, and now this guy, wants to detect speed. So let's do a capture. And we are capturing an image. So what we're going to do first is use OCR hosted on Google Cloud Services to detect the license plate number.
License plate number is Win Team.
Okay, so we have a system that talks back to us, and then we read both sets of LEDs on the rear view bumper, and we're hosting our image recognition algorithm on a faster computer, and we've sent our images to be processed. And here is our OpenCV algorithm, which detects the pattern of the LEDs lit up, and we see that we have a speed of 56 miles per hour. So we're using the LEDs to actually encode a decimal. Driving along, and then the car behind us has turned on its high beam. So let's turn on your high beam. And we can see that our high beams have been turned on. And now I am the car in front, so I am going to say, hey, this guy has turned on his high beam, so I want to tell him your high beams are on without yelling at him. So I'm going to go and say high beam. So if we look at the message displayed on our LEDs, so this is the signal for a high beam. And our system in the front car is going to do a capture and detect what this guy is trying to say. We do a capture, we figure out what the license plate is. Of course, for privacy reasons, we're not storing it anywhere, but we're leaving the option open of using other methods of communication. If the LEDs don't work, we can open up a WebSocket, send a text message. So we have correctly detected the license plate number, and now we are going to send over the images to our slightly powerful server which has a GPU for our image processing. And we see that this guy has said there's a high beam. So would you mind turning the high beam off? I'm going to turn that off. Okay. And then we can turn the high beam off like so, or lower beam. Okay. And we can do even a lower beam if he repeats the message. So that's a lower beam for us, and that's the high beam message.
All right.
One of the use cases that we have is if you want vehicle to vehicle to relay a communication of an emergency vehicle that might be approaching. So we can get, when we have self-driving cars, for example, the cars will know very quickly to move out of the way, and there's no human-induced lag. So in order to demonstrate this system, we have actually encoded messages for emergency vehicles. So let's do a warning for an emergency vehicle right now. And if you take a look at the red LEDs here, this is the message encoded for the emergency vehicle. And let's go ahead and do a capture on our good old capture process. And of course, we start off with the license plate number. So once again, the license plate number is a way of keeping record of who sent what message. And in states where we have front license plates, that could be a very good way of storing two-way messages as well.
Yeah, this is where editing.
Okay.
Cut.
Good.
Cut it?
Yeah.
Mm.
I know.
screen capture.
Okay, so here you edit it out.
Oh, internet is gone on my laptop.
Oh,
I
just
lost it.
great. One of our use cases is alerting vehicles of oncoming emergency rescue cruiser vehicles, and if we have a car-to-car communication which can be relayed, the warning about the emergency vehicle can be relayed much faster. And once we have things like assisted driving and automated vehicles, self-driving cars, they'll be able to move out of the way and make room for the emergency vehicle in a much more orderly manner. So here we have a normal setup, regular headlights, regular tail lights, and we are going to have the rear bumper, which is the car in front, warn the guy in front, the guy behind him about an oncoming emergency vehicle. So let's go to our dashboard and we say, okay, there's an emergency vehicle oncoming. So, and we see our LED pattern has changed into an oncoming emergency vehicle. The capture process on our other car initiates once again by taking the picture of the number plate. And we are just waiting on
License plate number is Win Team.
and we've just captured the images of the LEDs and we have sent it over to our slightly more powerful machine with a GPU for interpreting the signal. And right now we have the process going on, and it says
No, it didn't.
okay, now we are in the process of uploading our image files to our high-powered GPU to do some image processing and computer vision stuff. Okay, and then we have a warning that says the emergency vehicle is approaching. So these are the raw outputs from interpreting the LEDs that we have over here. And according to our protocol, this warning corresponds to an emergency vehicle being approached. Alright. One of the other use cases of inter-vehicle communication is communicating things like road hazard in somewhere down the road or somewhere in front, where the communication needs to be passed from the vehicle in front to the vehicle behind and relayed, so on and so forth. So we have defined in our protocol a message that indicates a road hazard that might tell the drivers behind that you might want to slow down or there's a slowdown coming ahead. So let's say we have this kind of situation. Let's initiate the process with changing so here's our regular, let's take a look at the regular headlights. So this is the regular backlights, and let's send them the slowing message. So this message corresponds to slowing. So as you can see, we have detected a road hazard signal, and this shows up corresponding to the LED pattern that we have in our setup right here. Okay, that's it. Sure. The last case that we're going to talk about is when there's a car behind you, for example, and the driver needs to peek ahead of you to see if he can overtake either from the left or the right side. Sometimes his field of view is blocked, maybe because it's dark and maybe because the car in front of him is larger and obstructs more of his view. So if there's a way for a good use case is if the car in front were to communicate the fact that there might be an oncoming car or there might be oncoming traffic, which makes it unsafe for the car behind to switch lanes or even attempt an overtake, or such a scenario. So let's go through the scenario. Once again, we have our headlights and our tail lights, and let's have the tail lights indicate an oncoming vehicle. So that is the the pattern for an oncoming vehicle, and let's start the capture process. So we can see, take a look at the LED patterns. That's the same pattern that we see here, which is the status bar thick message. You take that status there, and doing some filtering, we interpret this according to our protocol as an oncoming vehicle.